Hello, and welcome to this MathWorks webinar, using MATLAB and machine learning for algo trading. My name is Dan Owen, and I'm Industry Manager for Financial Services at the MathWorks. Also to add, this is going to be a demo-led webinar. All the demo code and data have been uploaded to MATLAB Central, so you'll be able to get your hands on this code yourselves, and we'll show you how to do that at the end of the webinar. So our agenda today is going to be fairly simple. We're going to pose our problem. Okay, so we're going to describe to you what we're trying to achieve. We're going to talk a little bit about predictive modeling using MATLAB. Then we'll start looking at the heart of the webinar today, which will be regression and machine learning for FX trading. Then we'll come to some conclusions and point you to some further resources before we have a Q&A at the end. Now, I should point out that I'm not here to advocate any particular trading strategy, factors, or methodology. I'm really just here to show you how easy it is for you to use MATLAB to test these kinds of models and backtest them on your data sets. So the challenge today, I'm going to take the persona of an FX trader, and I'm posing the question: can we use some information in the past to predict the future price and return of a currency pair? For example, I'm going to try and predict the 60-minute return of euro dollar using some techniques. We're going to use historical intraday data. So we're going to take some recent returns and some technical indicators, and we're going to try and create a predictive model, one that produces those returns. And then we're going to do this using a few techniques. We're going to look at regressions, we're going to look at machine learning, and then we're going to see how we can backtest this over a suitable period of time. So the world of predictive modeling, this is the utilizing mathematical languages to make predictions about the future. Once we have some kind of model trained, and we're going to look at regression and machine learning, then that is going to be something that accepts some inputs or predictors and generate for us some kind of outputs or response. This is an area that goes across many industries and application areas. As I said, we're looking in the context of algorithmic trading. Just one other example you can see here is maybe looking at building predictive models of electricity demand throughout the calendar year. When we come to talk about machine learning, this is a process that uses the data to try and understand the relationships within the variables and produces ultimately a program to perform some kind of task. If we look at this specific example here, this is the task of human activity detection, maybe taking sensor data from your mobile phones to try and understand, using accelerometers and such like, trying to predict what a human being is doing at any given time, walking, going upstairs, sitting down, etc. In the standard approach for this, we would write some code. Okay, we would work out by hand how to write the logic to split up the different activities a person has, or maybe even write down a formula that governs the equations that we care about. Machine learning is slightly different. It uses the data to understand this. It will take the data and also labeled responses, in this case, basically telling it what the answer is, in this case that being walking upstairs, sitting, and so on, and allowing the machine learning algorithm to determine the best way to link these inputs to the outputs. And this can, and basically understanding the nonlinear, linear, or even nonlinear dynamics that are governing these processes. So it's not putting in an equation, it's allowing the algorithm and the data to build the story. The machine learning workflow we're going to play with today is fairly simple. We're going to have some data loading, and then we could be doing some data processing. We can see here references to filters or PCAs. My data pre-processing is simply going to be factor creation. Then, in the context of machine learning, we're going to build a supervised learning problem where we're going to label our data to best allow the algorithm to classify, in our case, buys, sells, and holds. Then once we've iterated upon this model, we then need to be able to build predictions. So we need to take our new data sets, so maybe new prices, and send them through our data processing, our factor creation. And then we need to send them into the model, and that model is going to then give us our predictions, in this case, of 1 hour returns of the euro-dollar returns. In terms of our main demo today, we've got a few steps. The first of all is just to describe the data. Okay, so our data is stored in our data is 10 years of 1 minute bar prices, bid, ask, and mid price for the euro dollar currency. And this is stored in a timetable object. For those of you who are familiar with some of our standard data types within MATLAB, such as doubles or tables, you may not be familiar with the timetable object, which allows you to handle time-stamped data really easily. This has a few uses, a couple of which one might just be merging of data sources from different data sets. Supposing you have two data sets which are time-stamped, how can we merge them together? How can we join them? The timetable can do this for you. I'm going to use the timetable's flexibility in windowing into our data, quickly taking windows based on time out of my data for looking at in-sample and out-of-sample data sets. For factor creation, today we're going to be looking at a mixture of factors. We're going to take some toolbox factors. So we're going to take some relative strength index factors over varying windows and some MACDs, moving average, convergence, divergence. And these come from the financial toolbox. I should stress again, these are not factors that are necessarily the right ones to choose. They're just the ones that I've picked on today to play with. Then alongside that, we have our derived factors. And these are just going to be very simple n-minute returns back in the past, which we're then going to match up against future returns when we build our model. The model itself is simply going to take those factors, fit some kind of model, and attempt to predict positive or negative future returns using our current information. And given that prediction, so the prediction of buy or sell, we will trade upon this. The models, as I said, will be some linear regressions or stepwises and a classification tree. And then our backtesting is going to test it over 10 years, taking into account bid offer spread as a trading cost. And then we will just have a brief discussion on varying our length of in-sample and out-of-sample in this backtesting platform. So in the model training, we're going to start off with some linear models. Okay. So first of all, I'm going to show you how we can use FitLM from the Statistics and Machine Learning Toolbox, or Fit Linear Model, and stepwise to fit a quick linear model to this problem. Then we're also going to use our time range objects to create windows, a 2-month in sample and a 1-month out sample. I'm going to switch to MATLAB now, and specifically I'm going to look at the first script in my demo set. Okay, as I said, downloadable from MATLAB Central. We are going to take our data, which is going to be our currency pair. We're going to load it, and this is stored in a MATLAB map file. If we go back to MATLAB, we will see our prices. We've loaded in 3.8 million prices, mid, bid, and ask in this timetable construct. Once again, as I said, date-stamped data that we can do some nice things with. If we want to visualize our data, we can plot our currency pair from 2007 to 2017. And this is the data set we're going to be working against. Now this next section is going to calculate our predictor and response. I'm going to set it running before I start talking because it takes a short while to run. But what we have here is the ability to define a trading frequency. Okay, we are going to create our factors intraday. We can see here 5, 10, 15-minute returns. But then ultimately we're then going to downsample our data set onto the hour bar. Okay, so we are going to construct intraday 5-minute returns up to 1 hour returns. and also these technical indicators. Here is my handwritten code to stack up a number of signals that I want to create. You can add in your own ones here. This is where we have my MACD and my various length window RS index. And then this is going into my handwritten code, FX algo makes signals, which accepts all the inputs and returns a timetable X of our predictors and our Y, which is our future returns. We can see this has calculated. We've downsampled our prices down to around about 64,500 hourly bars for my factors. It's actually about 15 factors inside there. And then my Y, my future returns, we've done the return 1 hour in advance. This is the thing we're going to try and model using different techniques. I urge you to have a look at the FX Algorithmic signals just so you can see how it works and maybe validate that I've done the right thing, but hopefully you can do that at your own leisure. So the first thing we want to do now is we want to get an in sample. So we are going to test or train a model on 2 months worth of data. Now, the time table, we can window into that effectively using time. So we can do this using a time range object. The time range object allows us to set a time span, in this case, 1st of Jan 2007 to 28th of February 2007, and simply window into my X and Y matrices, or my timetables. I then, for the regression methodology, I need to cast them from a timetable into a table. But really, we're using the power of the time range to window into my date stamp data. Then, given our in sample, we want to train a linear model. To do this, I'm calling the function fitlm, and fitlm accepts a table. In this case, we're stacking up the X and Y. And fitlm assumes the last column is our response, the thing we're trying to model. We call fitlm, define a linear model, and if we go back to MATLAB, what we'll see is the model that's been fit. Okay, all our different factors, the coefficients that arise from them, and some of the statistics, t-stats and p-values for each one. Now what we have is a linear model object, okay? And our objects in MATLAB have methods. One of the methods we're going to call is the predict method. So let's call the predict method on my in-sample data, which should be pretty good. So we can actually get a return prediction from our data set given the model we've just fit. We're going to look at the effectiveness of the return prediction by backtesting this strategy. I'm going to basically say wherever the return prediction is greater than 0, I'm going to go long, and wherever the return prediction is less than 0, I'm going to go short. This is a very indiscriminate strategy. Realistically, we may be putting in some minimum return from the prediction before we actually trade. I'll be doing that later in the classification problem for the machine learning. Now, to backtest this, all I'm going to do is take the in-sample returns, multiply that by the positions, apply a cumulative product, and we can get a return graph. Okay, so here's our in-sample results. Does very well for our in-sample 2-month period. We can test this on the out of sample as well. Okay, so let's take the time range for March and run a similar process. So let's take the time range for March, run the process, run the prediction, calculate the returns, and we can see, not very good behavior. Not a great result, but one that we're going to try and improve upon. We'll persevere. We'll try and improve upon it. First of all, using a stepwise, but then we'll try and improve upon it using a machine learning algo. So the first step, as I said, is to try and look at a stepwise linear model. This is a kind of model where we can add all of the terms and allow the algorithm with it that has been coded up inside the stats toolbox to determine those inputs with the most predictive capabilities. I'm going to create a linear model, and I'm going to define a model where we start off with linear terms in all the factors. So I can see here the algorithm has run. It started removing those factors that it deemed were less statistically significant in this problem, and it's returned to us a much more compact model. Okay, it's thrown away those which it thinks are no good, or those terms which have less significance, and it's basically just kept 20-minute return, 25-minute return, and a 20-minute relative strength index. Once again, we can use the predict method on the in sample. Let's see how that performs. Okay, so this is not as good as the linear regression, quite obviously. And then let's run the same thing for the out of sample. Okay, also not very good, but broadly the same behavior. So if we're not getting any great improvement for moving to a stepwise, let's stick with a linear model. I'll do this just for ease of calculation and also time of calculation. This is much quicker to run than a stepwise, and we'll see this when we run our 10-year backtest. I'm just going to save the results for stage 2, which is going to be our machine learning problem. So what we've done there is for a single time window, 2 months in, 1 month out, I have fit a linear model and backtested it, but backtested a very indiscriminate algo, just waiting for any prediction greater or less than 0 and trading on it. What we want to do now, though, is repeat this process, but we're going to switch to a machine learning and specifically a supervised learning problem. In supervised learning, we're going to label our data records. So rather than just trying to build a regression model of return, we're going to take our returns, our future returns, and we're going to label them as buys, sells, or holds. We are going to do our labeling based on the median bid-offer spread in pips that we see in this currency pair. So wherever we see the return being greater than the spread, we can define that as a long trade. Where the future return is negative and less than this and greater than the spread, we're going to go short, and it's going to be 0 for all of the cases. Okay. So this is quite a simple process, and this is all in Demo 2 FX machine learning demo. So let's load in our data from before, our derived factors, and then once again, let's take our time range of the first 2 months, and this time we're creating a predictor table. Okay, we've windowed into the piece that we want. We're taking a predictor table, and our predictor table is just a standard table object with our returns in our labeled columns. Okay, so our 15 factors, and the next step is to fill out the response variable. We can do our response classification in a few lines of code. So I can look for the median bid-offer spread as being the minimum spread over which we wouldn't trade, or below which we wouldn't trade. I'm going to round this up to the nearest pip, okay, just because I can. And then we are going to add these to my predictor table. But we'll see them classified as -1s for sells, 1s for buys, and 0s for holds. Now this is what we're going to send into our machine learning algorithm, and this is what we're going to allow the data to try and best predict. -1, 1, and 0. Now I've taken one specific model, but let me just show you briefly how to run this data set through a series of different models using the Classification Learner app. The Classification Learner app is an app which comes as part of the Statistics and Machine Learning Toolbox, which guides you through the process of setting up a classification problem or running a classification problem. So once the app is up, I'm going to start a new session. Once we have that, the app has gone through and found all the variables inside our session, and I'm going to choose predictor table because that's the one we want, and I need to set my response, buy, sell, or hold is my response variable. I'm going to use cross-validation, so I can some random folds into the data set because we need to be able to validate the data set or validate the model that's generated. And I'm going to start my session. What we see first is a scatter plot of our data by where we color it by the classes. We can see blues for sells, reds for holds, and yellows for buys. And we maybe don't see as much structure as we'd hoped in this data set, but we're still going to persevere and we're going to train a bunch of models on this data set. Now we've automated this process for you. So I can choose all quick to train models. I press train, and now MATLAB will go and train a series of models on our data sets. We can see that the tree, which is the one I'm going to choose, is the best one we have. But let's say we want to look at the cubic k nearest neighbor algorithm. We can look at the results. We can look at our confusion matrix, which basically shows us the levels of misclassification of each of the different classes. This may not be a great one. We don't see if the model was perfect, we'd see green down the diagonal and no reds. But we're going to persevere once again just because we can. So I'm going to close the app, and in my script I have by default chosen that best model. Okay, so this is the best performing model that we had, just on a pure score basis. I can fit this by hand, so I can take my predictor table and take the factors and the predictor responses, and I can fit my model. We can see what the model looks like. Okay, so we can see the tree that comes out of this. And it's not a great one, okay? I'll admit that. Maybe that's because of the size of data set. Maybe it's because of the factors we're putting in. I would leave that to you as an exercise to work out which factors are really more suited to this kind of problem. But we're visualizing this quickly, as we can see it's picking 10-minute return and 25-minute return, and that's all it's saying. Now, this is only for that first month, okay? When we build models for much across the entire time series, I'm not going to visualize all the models, but you'll see all the models, or actually all the models, all the trees are going to be saved off, and you can visualize those at your leisure at some point, because there are going to be lots of different structures coming out, and we're not going to analyze all of them. But in this first instance, in this first time window, we've created a very simple model, but that's what the machine learning algo has decided for us. So once we have our tree, we can predict it, okay, as before. So we can take the predictor table, take the in sample, and we can predict the performance. In sample, it still does pretty good. And let's look at the out of sample. Once again, taking the March time range as our time range in question, running the prediction, and here we see a slight improvement, okay? Here we see a definite improvement of performance in the out of sample period. So now we're going to take this method and backtest this across our history. Okay. So to do this, we are going to kind of run our algorithm backtesting platform. I'm going to use MATLAB scripting as our backtesting environment. And I'm just going to loop through my data set using date time variables and date shift methods. At each iteration within our data set, I'm going to fit a linear model and also fit the tree at each iteration, pick up the returns, and then optionally, we're going to add transaction costs wherever we trade. This we're going to base on the bid-ask spread again. So this script, demo 3, FX regression batch, I have two of them. I have one that is 1 month in, 1 month out. Okay, this is much simpler to code up, but this script is going to start off by loading in our data. Okay, and then I'm going to set up my initial window. And I'm going to set up my initial window as being a date time object of 1st of Jan 2007. And then I'm going to use one of the methods on that date time object, namely date shift. I'm going to shift that to the end of the month. It's going to create my window being 1st of Jan to the end of Jan. Here is where we can implement our trading costs. Let's run this first without any trading costs, but we'll see how we implement the trading costs inside, and I'm just going to create it as the median spread return that we care about. We're going to define a minimum pip width for the classification. So we're going to say we need a minimum pip width of 1.5 pips before we classify or trade. And then the next step is to use a while loop. We are going to loop through our data, and then I'm going to shift our data sets forwards and basically run our models on this data. So I'm going to create an in sample of 1 month, an outer sample in 1 month. I have coded up those two processes. The FX regression workflow has been coded up here as some simple MATLAB code, and we can see here how we apply the transaction costs. Transaction costs are only applied in this case where we have a change in position. So here we have the positions determined by the model, and here we only cross the spread where we actually change our position. So if we have a hold and a hold, we're not trading. If we had a hold to a buy, obviously we're going to trade, and we're going to cross some of the spread. Okay, so this is where we're implementing that trading cost into this result. So both of these, the FX regression model and the FX machine learning model, are just bits of functional versions of the scripts we saw earlier on. Then we're going to stack up the trades, stack up the returns, and then we're going to shift our in sample on. So the new in sample is the old out of sample, and then we're just going to run through everything. So if I run this and move back to the MATLAB command window, we'll see this is fairly quick. Okay, even though every month we're fitting a model and testing the model, it is quite a quick platform to run. So here we can see the performance. So we can see quite easily that there maybe seems to be some value in running a classification tree over a regression model. We can throw in the trading costs. So let's add in the trading costs into our problem. Go back to the command window, and we should see quite quickly the result of this where we've applied a trading cost. So even with maybe a relatively conservative trading cost, we can see that there may be some value in this strategy. Okay, we're getting, a decent return over 10 years. So nothing to write home about, but at least there's maybe something there. But certainly something above and beyond the plain regression tree. I would leave it to you as an exercise, if you want to have a look at this one. This second demo 3 FX regression looks at a 1-year in sample and a 1 month out sample. Really just leveraging the time objects we have before. And we'll see this is now something that takes a little bit longer to run because obviously our data sets are much bigger for the training portion, but we're doing the same process. We're running a linear model. We're also running a tree classification, and then we're back testing it. You can see how we get a pretty good performance on this one. And also if we switched on the trading costs in this one, we will see that in a similar process, adding the trading costs, we can see that in this instance, the classification tree does outperform the regression model quite considerably. Okay, so there we go. So there we have some results. This time, as I said, 1 year in sample, 1 month out sample. Okay, have a look at the code. You'll see how easy it has been to set up the problem. Using our date time objects and some of the new functionality like using functions like calendar duration or cal days to window into our data sets easily and quickly. Okay, now we have built a simple model and we back tested it. One thing that I would urge you to do, and this was when I was researching this problem, was trying to make sure that we weren't just lucky. As I said, I'm not trying to um, suggest any specific trading style or factors or methodology, but I did want to make sure that what we had, because the results we have here are quite stark in terms of the difference between the regression and the classification trees, was not lucky. So what I have in the data in the download that you can download for the demo is a script. It's script 4. Script 4 is going to take a little bit longer to run, so I won't run it today, but it tests for starting point sensitivity. What that means is it will run the model starting at every minute possible in the first hour of the data set. And I do this because, it's really a note of caution that unfortunately we were kind of lucky. Okay. If we look at the results from this, we can see a distinct spread of results based on which minute of the day we've started upon. I would use this as maybe a springboard to have a think really more about the factors you're using and the kind of regression models or the kinds of machine learning algorithms you're using. But don't go out and suddenly start trading this model. Look to see this from the results here where we have a distinct spread of results based on the starting minute. So what we've seen today and any conclusions we can bring out, so we've shown how we can use MATLAB and, create factors for FX trading. I've chosen a couple of specific factors, once again, stressing then, your mileage may vary. But we've seen how we can build and test regression models and machine learning models for returns prediction. Okay. And also we've backtested this strategy whilst incorporating trading costs. Okay, all within the context of a simple MATLAB scripting environment. As I said, the code and data from today's session can already be found on MathWorks File Exchange. If you know how to go to MATLAB File Exchange and MATLAB Central, you can search for the webinar files, and the MathWorks Quant team is the username, and you can download those files today. Some other resources you may be interested in. We have some discovery pages. So if you're interested in delving a little bit more into machine learning techniques or predictive analytics, these two URLs here can guide you into some nice resources, examples, customer user stories, and maybe even some further demos. So with that, I just want to say thank you for your attention and your attendance today. Thanks very much.